In this video series, we will be reviewing the process of creating a custom Checkmate probe to use with the Checkmate programming module. The basic workflow consists of 3 steps. First, create a 3D assembly model of the probe in SOLIDWORKS. Then second, using the Probe Builder 2 add-on, we add the Checkmate probe properties to that probe model. And finally, step 3 is to save the finished probe to a Checkmate PRB probe file. Making a probe rack configuration is similar to making a single probe, except we load all of the components into the assembly file, mate them up and make them virtual as before, but then we define which buildup belongs to which rack configuration. So let's start with loading a PH10 with an SP20 for a probe rack. We have one of these made just for you in the Probe Builder 2 folder. The first component to bring in is the SP20 adapter that our styli will be connected to. Then, let's load a stylus extension and then a stylus tip. Just like before, we need to mate these pieces together. Starting at the bottom, we mate them concentrically first to line them up. And then coincident to make them flush. We repeat the mate command to connect the stylus to the SP20 adapter. Concentric, and then coincident. At this point, we have completed creating the geometry of what will be sitting in the probe rack, although we still need to repeat the mate command to connect it to the head. Concentric, and then coincident. The coincident is a little tricky because the 2 faces where they mate are very tiny flat faces. Ah, perfect. Now, the SP20 adapter, the stylus extension, and the stylus tip are still tied to the external files that we loaded from our hard drive. As before, we need to detach them from their external file by right-clicking on each component and selecting Make Virtual. You can see that the 3 new components are now marked as copies. Probe building tip. Although we brought in the separate components, the SP20 adapter, the stylus extension, and the stylus tip SLD PRT files into the file separately, and then we mated them together, you can build these components first in a separate SLD PRT file and then just insert that and mate it to the probe head. And that's exactly what we're going to do for the next 2 rack positions. First, we need to hide the CAD geometry for the rack position geometry we just created before we can load in the geometry for the next rack position. Back in the Probe Component Library folder, in the Probe Builder 2 folder, that contains the files that we already have built for you, is a folder called Styli Configurations. Just like with that probe building tip, we have some rack buildups that we have previously made. Let's go get one. Now we just have to mate this buildup to the main head adapter. Concentric, and then coincident. We make it virtual, and then we hide it. Let's load in one more already made rack buildup. This time we'll select a star probe solid part file. And we'll mate it to the main body. And finally, we'll make it a virtual copy. Our probe rack has 3 stations, so we are finished importing and mating the geometry for the 3 probe rack positions. First, let's unhide all of our geometry. They will automatically be hidden later. Now we want to select the components that are common to all 3 probes in each rack. I'm referring to the PH10 and TP20. Then we right-click and select Configure Component. Each highlighted component is shown in columns, and each row represents a configuration. The configuration called Default will be our Rack 1 configuration, and we will rename it later because we can't do it here. Clicking in the box below Default allows us to type in the name of our next configuration, Rack Position 2. Clicking in the bottom field again, let's create a third configuration called Rack Position 3. You can see in each field, each component can be suppressed from the configuration. Since these components are the main head, we will want to see them for each rack position, and therefore we will not suppress any of these components. Just hit Apply and OK. Now we will highlight the components that will be in Rack Position 1. Right-click and select Configure Component again. In the resulting pop-up box, we only see the component columns of the highlighted components. Since these components are going to be in Rack Position 1, we want to suppress them from configurations 2 and 3, and we click the check marks accordingly and then hit Apply and OK. Let's repeat that process for the single component that we loaded that's going to go into Rack Position 2. You can probably guess that we want to suppress it from Rack Position 1 and 3. Finally, let's repeat that process for the star probe in Rack Position 3, suppressing it from Rack Position 1 and 2. Remember, we wanted to change the name of the first default configuration? Well, if we click on the Configuration Manager tab, we can edit each of the 3 configurations. We simply select the configuration, wait for the graphics to update, and then right-click and select Properties. For the default configuration, we will edit the name to Rack Position 1, and we'll type in a small description for it. Some people like to enter the buildup that we have in the description into the name field. You can do that too. I just find it easier for me to enter the rack position number. We select the second configuration, wait for the graphics to update, and then right-click and select Properties. Here we will just edit the description field. We will select the third configuration, wait for the graphics to update, and then right-click and select Properties. Here we will just edit the description field. We are finished step 1. Let's save the solid assembly file now, and then you can move on to the second video, step 2.